Alright, this video is about how to graph a sine and a cosine graph, specifically looking at its amplitude and its period, which I know you don't know what that means yet, but you will. Alright, so new parent functions. Just like you learned parent functions in Algebra 1, Algebra 2, we're adding two new parent functions to it, and they come from the unit circle. Okay, so we're going to look at the sine parent function. So we're looking at the sine at different angles. And the angles I want to focus on are the angle 0, pi over 2, pi, and 3 pi over 2. And remember, 0 and 2 pi are really the same thing, right? So, okay, so we're talking about sine. Remember, sine relates to the y value. Sine of theta is the y value at the different points. So at 0 and at 2 pi, what is my y value? Well, it is 0. At pi over 2, what's the y value? It's 1. At pi, what's the y value? At pi, what's the y value? Y value is 0. At 3 pi over 2, the y value is negative 1. And then if I kept going around the circle to 2 pi, I would end up back at 0. So all I've done is gone around the unit circle, looking at the sine values at my landmark angles. Okay, I could do it at every single angle in between. That's a lot of points to plot, and I want to keep it as simple as I can. So when you graph this, there's your x and there's your y. Okay, notice your y values don't get any higher than 1 and negative 1. And your x-axis is in radians now. So you go from 0, and we've gone the full circle, which is 2 pi, which is at 2 pi. Now, I want to just split the x-axis up into, okay, it's 0, 2 pi. What would be in the middle is pi. And then look at our other points. Pi over 2, and then 3 pi over 2. All right, so these are key points you want to know in your sine curve. So now we'll plot our points. At 0, the y value was 0. At pi over 2, the y value is 1. At pi, the y value is 0. 3 pi over 2, the y value is negative 1. And at 2 pi, it is 0. So if I connect my curve, it's a curve, by the way, not a straight line, it's a curve. Remember coterminal angles? They can keep going around and around and around. That just means that the sine function can keep going around and around and around. And it's going to cycle back and forth. But what you see here, from 0 to 2 pi is considered one period. Okay? How long does it take for it to reach all its points, basically? One period. And it took from 0 to 2 pi. So we see the length of the period is 2 pi. The amplitude is the height from the midline. Okay, the midline in this case is my x-axis. And how far away did it get? Well, I got it 1 unit away up, 1 unit away down. So my amplitude is 1. Now let's think about domain. Okay, we said this thing keeps going on forever and ever and ever, like this little picture down here. You can see it's a continuous curve. And so that means my domain goes forever in the negative direction and forever in the positive direction. So it's negative infinity to positive infinity. And lastly, think about the range of our sine function. What's the highest the y value gets? It's a 1. What's the lowest? It's a negative 1. So if you remember our brackets, it stops there. Can't go any further. So those are your key points for the sine curve. Notice it makes kind of an S, a backwards upside down S, across the x-axis. Key points at 0, 0, 1, and negative 1. All right, you're going to pause the video, write this in on your parent function pink paper. Okay, to graph the cosine parent function, we're going to do the same thing we did before. Starting at 0, going to pi over 2, to pi, 3 pi over 2, and then to 2 pi. We're on the circle looking at cosine values. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi is the same as 0, right? So remember cosine, that's your x values, remember? So look at your point at 0. What's the x value there? It's a 1. Pi over 2, what's the x value? 0. Pi, x value is negative 1. 3 pi over 2, what's my x value? It is 0. So I'm going to graph these points like we did before. My x-axis are my angles, so it goes from 0 to a full circle, which is 2 pi. I'm going to mark it at pi in the middle, pi over 2, and then 3 pi over 2. And then look at my y values. From 1 to negative 1 is where we go. So here's 1. Here's negative 1. So then I plot my points. At 0, my graph starts at 1. At pi over 2, it's at 0. At pi, down at negative 1. 3 pi over 2, it's at 0. And 2 pi, it is back up to 1. So it too is a continuous curve through these points. And what you see here is one period of the function. This thing keeps going on forever in either direction. Same version. Look at this picture at the bottom here. You see it. Here's one period that we just graphed. That's what we just graphed up there. But see, it continues on forever in both directions. So let's look at our values. The amplitude, the distance from the midline. How many units did it go up and down? Only 1 unit. The period, how long did it take to complete the cycle before it started repeating? Well, it took all the way to 2 pi, the full circle. Domain, what are the x values where this exists? Negative infinity to positive infinity. Range, what's the lowest y value? Negative 1. The highest y value is a 1. Okay, so pause the video, write this on your peak parent function sheet, and then we'll be ready to move on to the next step. All right, some definitions. Amplitude, vertical stretch and shrink. All right, that's what we talked about with our curves. How far does it come off the midline, wherever the midline happens to be? Okay, that's my amplitude. Period is the horizontal stretch or shrink for the cycle. So if this is one cycle, the length of time it takes, I guess you could call it time, x values, is the period. Now sometimes this can get shrunk, squeezed together, or stretched out, and you'll see what I mean as we move along through this. Now for the parent functions, they look like this: a sine b of x or a cosine b of x. So in order to just look at the function, the equation, and find the amplitude, all you do is look at that a value and you take the absolute value of it. It's that simple. Take the a value and that's the absolute value. To find the period of a function, you take the b value and you divide it 2 pi by b. Why is it 2 pi? Because it took a full circle for the period before. So I'm going to take 2 pi and then divide whatever b is in the equation, and that'll tell me what this value is. How long did it take for this period to complete on my specific graph? Hopefully this will make sense as we do some examples. All right, so look at this. We're just setting the equations right now, finding amplitude and period. So example 1, find the amplitude. Well, here's a. The absolute value of 2 is 2, so my amplitude is 2. The period, you do 2 pi divided by b. Well, in this case, there's a 1 here for b, so it's just 2 pi divided by 1, so my period is 2 pi. Example 2, amplitude. Well, here's a. I want the absolute value of negative 3, which would be a positive 3. The period would be 2 pi divided by b, which is 10. Always reduce, so it's pi over 5. And I'll show you how to graph this in a moment. Example 3, amplitude. 1/2, absolute value of 1/2 is 1/2. B here is a fraction, so 2 pi divided by 2/3. Okay, you got to keep it, change it, flip it. So 2 pi over 1 times, that's my change it, flip the bottom. Those will cancel, and then my period is 3 pi. Amplitude on this is positive 1/2, or it's just 1/2. Absolute value is always positive. And then the period here, well, that's weird. Here's b, pi over 4. So I have 2 pi divided by pi over 4. Don't freak out, just do it. So 2 pi over 1 times, flip the bottom, 4 over pi. So my pi's will cancel, and my period is simply an 8. And yes, that too can happen as well. Now, let's talk about graphing this. All right, so when you graph the sine and the cosine, the amplitude changes. When a is something besides 1, what do you do? Well, remember your parent function, with sine curve, it went from a positive 1 down to a negative 1, right? So it's going to follow the same shape, it's just the y values are going to change. So all you're going to do is multiply the y value in your graph, which is 1 and negative 1, by the a value in the equation. Notice it's not the absolute value, it's just the a. So on example 2 here, or 3, sorry. The amplitude, what is a 2, right? The period, that's a 1, so my period is 2 pi divided by 1, which is 2 pi. Alright, so I'm still going to 2 pi. My values look about the same as my parent function, so just take that from your parent function. Now, what used to be a 1 and a negative 1, I'm just going to multiply by 2. So now it's a 2 and a negative 2. So my graph starts at 0, it's going to come up to 2, down here to pi, down to negative 2, and up to 0 again. So it's the distance here has doubled, basically, times 2. On this example, example 4, the amplitude, remember absolute value of A is positive 1/2. Period is, the B is a 1, so the period is 2 pi divided by 1, or 2 pi. So again, same values as your parent function on this. 1, -1 on my cosine curve. Remember, my cosine curve looks like this from 1 to -1. It starts at 1. So instead of starting at 1, I'm going to take that 1 and multiply by -1/2. So it's going to be down here. So my curve's going to start here. So that negative is essentially flipping it over the x-axis. And where it was at -1, it's going to become, okay, so this is -1/2 and positive 1/2, because I've got to multiply the -1 times -1/2, which will give me positive 1/2. So my curve is going to come only to here. It's kind of smushing it down and flipping it over. Okay, so that's what one period of that looks like. Notice it just flipped it over because of the negative sign, and it shrunk the amplitude by 1/2. Okay, so graphing sine and cosine with period changes. Okay, I've corrected my example numbers. This is number 7 now. Sorry for any inconvenience there. Okay, so when B, right here, is something more than a 1, the period is going to change. So I'm talking about the sine graph here. Normally looks like this. Normally ends at 2 pi. That's going to change because there's a 6 here. So I need to figure this out. Okay, so 2 pi divided by 6 is pi over 3, right? So the end of my cycle, it will end at pi over 3. It will begin at 0 like always. To find the middle of that, I'm going to take the pi over 3 and multiply by 1/2, which is going to give me pi over 6. All right, so now I have my major landmarks there. The amplitude, if you look at the equation, is just a 1, and the period we calculated was pi over 3. Okay, so the amplitude is no different than the parent function. It's not reflected, so it's going to make the same shape. It's just going to end at pi over 3 this time. So it's going to look like this. There it is. That's the sine curve with the period change. Look at number 8. Look at this period change. The amplitude here, let's look at A, is just a 1. The period is, let's see, it's going to be 2 pi divided by pi over 6. All right, so I've got to keep it, change it, flip it, keep the top, change to multiply, flip it on the bottom. So the pi's will cancel, and the period is 12, which feels strange, but that's what it is. Now, think about your parent function for cosine. Usually ends at 2 pi, usually starts at 1, and it does this thing, okay? So right in the middle, it's at its low point, and it starts at the high point. So instead of ending at 2 pi like my parent function will, this one's going to end at 12. So the middle then is 6, and then if I break it into fourths, there's 3 and there's 9. Amplitude is still 1, so it's 1 and -1. And if the cosine starts at 1, this one's still going to start at 1. It's going to reach its low point right in the middle, which is now 6, and go back to its high point at the end of the period, which now is at 12. So you can see that labeling your axis is extremely important, and using the correct parent function, very important as well. All right, what about a combo? Let's do this together, all together. Amplitude is positive 4, because remember amplitude is always positive. Period. 2 pi divided by 2, which means it's just pi. All right, now don't forget the negative here. That means it's going to reflect. My x values are 0 all the way to pi now. Split that in half, pi over 2. So my curve is still going to have this shape. Amplitude, instead of being at 1 and -1, it's going to jump to 4 and -4. And my curves, remember, at 0 in the beginning, middle, and end. It's going to start at -4, start at 0, and then go. Curve's going to start at 0, and it's just going to flip this curve upside down. So when it usually goes up, it's going to go down first this time. And there's roughly what it should look like, okay? Lots of little steps here. Find the amplitude, find the period, look for any reflections, and put it all together on a graph, okay? Use those parent function notes to help you get these pictures in your mind and be able to make transformations. Okay, for class tomorrow, I want you to try this example in your notes. I know there's nothing you can type in the WISC, but at least try this example And we'll talk about this in any questions in class tomorrow.